variables are related. So estuary are meeting points between rivers and seas. So historically, estuaries are important. Most civilizations began uh, at estuaries because historically rivers are the main mode of transportation. Rivers also provide irrigation for agriculture and food from the fish. Okay, so it became an important point for civilization to develop. Okay, also if you as we are microbiologists, uh, rivers also transport waste. So historically, waste are either uh, transport either removed by rivers or ducts or buried underground. Okay, so estuaries are meeting points between rivers and seas. So we have uh, so where does an estuary start and where does an estuary end? Okay, I mean, if you're studying a river mouth, you go to the river. So where does the estuary begin and where does the estuary end? So you need to have some kind of measurement to help you set the boundary. Okay, and usually the variable that we measure is salinity. Okay, salinity measures the amount of salt in the water. Okay, since seawater has about 30 parts per thousand salt salinity, and fresh water is essentially zero. So the upper margin boundary of the upper boundary of the estuary is where you no longer observe influence from the seawater. Okay, so influence uh, could also be due to tidal action. So sometimes you observe very low salinity, maybe about 1 or 0 point something, but you observe that the level of the river seems to be related to the tides. Okay, is going up and down according to the tides. So it is still considered an estuary because there is tidal action. It is still influenced by tidal action. Okay, so that will be your upper or fluvial estuary. That demarcates the upper limits of your estuary, where you still observe salinity and you still observe tidal action. So the middle estuary is brackish water. Brackish water is usually about 5 parts per thousand to about 25 parts per thousand salinity. So that's the brackish water range. Okay, so this is where there's a lot of mixing between seawater and fresh water. Okay, then the lower or marine estuary is the part that is connected to the sea and where the salinity can go all the way up to 33 parts per thousand. Okay, so this is considered the estuary. Because estuary is a meeting point between rivers and seas, both the river and the sea are very, very different waters. It is a very difficult place to study, okay? Because of wide fluctuations in temperature, in salinity, in nutrients, because of the constant mixing and the constant mixing between two different sources of water. That's why estuary is, in order to study an estuary, the first thing you got to do is you have to study the uh, physical movement of the water first. Okay. We have to understand how the river and the seas are mixing in the river mouth. If not, you will not be able to understand the results that you are getting. Okay. So from the geomorphology of estuaries, you can actually guess certain things. Okay. If your estuary is a very straight, deep channel, that means the flow rates of the river is very fast. Okay, so fast flow rates will cut deep channels and straight channels for the river mouth. But slow river flow rates will does not have as much force and will follow the meandering channel, which means it will follow the geological structure more. Okay, so though because it doesn't have that much force, it is also shallower than a estuary with a fast river flow rate. Okay, and because of slow rivers also, if it's a slow river flow rate, there will be higher sedimentation, and that leads to delta formation. That is important for most of the famous agriculture uh, regions in the world. Okay, so the geomorphology of estuaries depends on flow rates and the geological structure. Geological structure depends on the type of rock, the type of bedrock. Okay, some are harder to be eroded. So both geological structure and the river flow rate will determine the shape of your river mouth. Okay, as I mentioned, estuaries are very dynamic habitats. Okay, with high variability in salinity, turbidity, temperature, and nutrients. Because of this, not many uh, organisms do well in estuaries. Okay, most of the organisms are either riverine or sea. Because when there's a lot of fluctuation in salinity, turbidity, temperature, and nutrients, it causes a lot of stress towards the organisms. So most of the organisms that you see in estuaries are either flushed down by the rivers or seas. Okay, it is very hard to prove that an organism is actually thriving in an estuary. Okay, to be able to thrive in an estuary, you have to have a very wide uh, tolerance towards all these variables. Okay, so the variability in salinity, turbidity, temperature, and nutrients are related to the volume and flow rates of the freshwater and seawater. Okay, in the context of flushing rates and residence time. So flushing rates and residence time, basically it is used to describe uh, how long it takes for the water volume in the river mouth to be replaced by the river water. So if it's a long residence time, that means the river mouth is very big, and then the river flow rate is low, so it takes a long time for the water in the estuary to be refreshed. Okay, so if it takes a long time for the water to be refreshed, means any contamination in the river mouth will take a longer time to be flushed out. Okay, that's why it is important to know residence time and flushing rates in a river mouth. Okay, so there are types of estuaries. You can divide estuaries according to the how the river water and the sea water interacts. Okay, so the first is actually the highly stratified salt-rich estuary. So this is where the river discharge is very, very strong. Okay, so the river discharge is large rivers with a lot of water coming out into the river mouth. Okay, because the fresh water has about zero salinity, it is lighter than the seawater. Okay, and because of this large amount of seawater, of river water, it actually creates a highly stratified estuary where the seawater and the fresh river water doesn't mix well. Okay, so a little bit of diffusion here, but it doesn't mix well. So there is a strong halocline here. Okay, so this is a first type of an estuary, highly stratified salt-rich estuary. The second type is a partially mixed, moderately stratified. The river flow is not that strong, okay, less strong. So you will have more of a turbulence and more mixing. So you can see that the seawater, the salinity decreases because there is mixing. So the halocline is also less distinct. So another type is your vertically homogeneous with intense tidal flow. So this is where the seawater is strong. Okay, you have very strong tidal action. So whatever fresh water that flows into the river mouth is immediately mixed by the sea. Okay, so there is actually vertical homogeneity. So it is vertical mixing. So you have sections of the water here where the salinity increases as it goes out into the sea. So it's homogeneous for the whole water column at each distance from the river mouth. So there is no halocline observed at all. Okay, so there is strong turbulent mixing and it's vertically homogeneous. So the last type of estuary is a fjord. Okay, these are usually uh, very well studied in the Baltics. Okay, because they have a lot of these fjords where you have the presence of a sill and then you have stagnant bottom water here. Okay, so your river flows out and the bottom water here, the sea water here, remains stagnant. Okay, and there is very little mixing. Okay, so this geomorphological structure here forms because of the glacier, action of the glacier. So the glacier carved out this part and then it stopped here. Okay, so over time the glacier melted and you have the bedrock remaining. Okay, so this kind of fjords are well studied because of the stagnant water here. It is now known that a lot of anaerobic processes occur in these waters, anaerobic processes. Okay, so it's well studied because of it's interesting from the point of view of anaerobes. Okay, so imagine estuaries as moving from a calcium carbonate dominated river water to a sodium chloride dominated seawater. Okay, so estuaries have steep gradients in ionic strength. Okay, from a 0 parts per thousand to 30 parts per thousand in salt concentration. So the increase in ionic strength actually destabilizes colloidal metals and causing it to flocculate and sink. Okay, you remember sodium chloride in the seawater is actually in ion states, so it's sodium positive and chloride negative. So all these uh, charges, ionic charges that are available, allows flocculation, which means it allows particles to come together. Okay, so when these aggregates come together, they are heavy and then they sink. So based on this characteristic of an estuary, it is now known that estuaries act as important filters. So filters that actually clean the river water before releasing into the sea. A lot of pollutants, a lot of materials are actually aggregated and sunk in the river mouth. Okay, so estuaries act as filters. Now we also know mangroves act as filters. Mangroves because they are clay. Their clay are negatively charged and can bind a lot of positively charged materials. Okay, so mangroves are good as filters. Estuaries are also important as filters. So how do you know whether your estuary is acting as a filter, removing components from the river water? So usually they will use a mixing graph to study the reactivity of the estuary. Okay, so your x-axis is conservative index. So usually we choose salinity because salinity is not controlled by other processes other than physical mixing. So from 0 to 30, it is actually a very good indicator of freshwater to seawater. So salinity is usually used for the x-axis variable. So y-axis is the component that you are studying. Okay, so if you measure it from upstream all the way to the river mouth and you find a straight line like this, that means there is no reaction. Uh, there is no reaction with the estuary. It is conservative mixing only. It decreases from the river to the sea mainly due to just physical mixing, similar to salt. Okay, there is no reaction. Okay, so this is the theoretical dilution line. However, if you see a curved graph like this, that means it is non-conservative. Your components are actually removed from the estuary. No, your components are actually removed by the estuary. Okay? But if you see a graph like this, that means the estuary is actually adding on to your component. Okay? So this is the theoretical dilution line without any reaction. This is where there's a removal by the estuary, and here is where there is an addition by the estuary. So if you're studying a specific component and you want to see how your component is reacting as it moves from the river to the sea, you can use a mixing graph. Okay, mixing graph.